Hi, and welcome back to the Babylon.js channel. My name is Nick. You can find me on the forums all the time. I go by the name of Drigax, and today I'm here to show you. Actually, I'm here today on behalf of our amazing community. Special thanks to Andre Derrigan. He suggested that I revisit the Toon Shader series and try to turn it into a comic book ink style shader. So let me show you what I mean by that. Uh, you can see the similarity to the toon shader that we made previously. We have our lit portions, we have our kinda lit portions, and we have our dark portions. And we try to make the distinction between these levels of light as dramatic as possible. So here, I feel like what really makes this special as a comic style shader is we kind of wash out that surface color. We're not really showing the shininess or glossiness of the surface anymore with the specular, and we don't really care about where the light source in the scene is. So you can see the light somewhere over here shining on Batman, and the lit portion here is just completely washed out in white. We have this somewhat kind of lit portion here. You can see the dithering and shading pattern used to get that dimly lit part of Batman's permanent scowl. And you can see the dark portion is just completely black and unlit. And I feel like that's what really makes this like a special as like a comic shader, is just trying to capture like what can contribute to making that sort of dithering pattern. So as is tradition, we go with the finished product first. So you can see here, I just have this model of I think it's an F18. We can see that our fully lit portions are completely lit, the dark portions are completely dark, and the intermediate portions are filled with what I call it the chowder shader. I don't know if you've ever seen this cartoon called Chowder, but if you watch that cartoon, get back to me, you know exactly what I mean. So we're using screen space to fill in our dithering pattern. So you kind of get a very dynamic effect using this. I personally think it's super cool, and the best part about this is that this is completely UV independent. So you can make your model, you don't really need to unwrap it, and you can still get a pretty nice comic style look. Otherwise, you can always try to fill in with like an actual dithering texture, or may also go into how to make this dithering effect programmatically. But this is a very simple way to get off the ground and just exploring more non-photorealistic styles. So let's go back to where we left off before. We have our two-tone shader, lit, unlit. We have a specular highlight here. We have some rim lighting here. And so the first order of business is just remove the specular highlight, because I don't really think we need it anymore. So we can see here is where we calculate our specular light. Let me just plug that into our lighting calculation here. And you can see, boom, specular light, or specular highlight. So let's remove that from here. I'm going to first reorganize these nodes just to make them a little bit easier to work with. So we're going to relocate where we calculate our specular light, and let's just completely remove that from our lighting calculation. Just as a sanity check here, we can just double check that this is our specular highlight. Perfect. So let's remove that. Let's plug this back in, and let's just remove this node here because I don't think we need it anymore. Boom. All right, specular has been removed. And so now, first off, let me just change this. Since we're working in Comic Land, it's only fair that we use black and white. So we'll change our surface color to be white, and we're going to darken our ambient a bit, just so we can get that real dynamic shading. We want this to be as harsh as possible. Okay, that's a bit better. So now we can kind of make sense of the three different light sources. So the second order of business is just we need to remove pretty much everything that contributes to our specular lighting. We don't need the half vector anymore. Don't need our specular factor anymore. Do we need the diffuse cutoff? Of course we do. And we of course need n.l for our diffuse lighting calculation. All right, so now that we removed all the stuff we don't need, let's start to work on this. So originally we have a rim lighting calculation here where we take the rim, so we take the outside of this vector, so we take the outside, we color in stronger the parts of the mesh that are not facing the camera as much. So that's just our cheap and easy edge detection function. So what we can do here is just remove the contribution of the light. We don't really care so much what the light is anymore. So what we can do is just take the 1 minus n dot v, so that's the normal vector, dot it with the view direction. So we'll take where our camera is looking at the mesh and what faces align with where the camera is looking. And we're just going to override the calculation that uses the light vector. So as you can see here, we get this cheap and easy outline effect. So now what we can just, what we can do actually, we can take the n.v, we can plug this into our rim factor, just so we can get this scaling with the intensity. I still want to be able to control how bright or dim this is. So I'll plug this back into here. And so now if I change my rim intensity, this will change the strength of my outline. So 0.2, 0.3, 0.4. So the higher the value goes, the thinner the outline gets. But if the smaller it goes, the stronger it gets. I'm not sure how, yeah, we only get to 3 significant digits here. But you can see what I mean here. And as a matter of fact, I don't really think we want to use the power anymore. So let's remove this block and we're going to replace it with a scale. We want this to be linearly controllable rather than exponentially controllable. So I'm going to throw in a scale block right here. We can reattach our factor. We can reattach our n.v calculation. We can remove this multiply because we don't need it anymore. And then we can plug that into our light rim. There we go. So let's make this a bit stronger. And we can see here, that's a strength of 1. So it's kind of hard to comprehend looking at a sphere. So let's grab our toroid so we can kind of understand this a bit more. So the more this looks at the camera, the weaker the outline gets. And so now let's just tone this down a bit. I believe in my experimenting, I found that a value of 0.6 works pretty well for that subtle outline. And we just want to decrease the cutoff so it shows through a bit stronger. So we want 0.4. Let's try that one. Oh, 0.4 actually looks pretty well. All right. So now if we increase the cutoff here, you'll see that a cutoff of 1 gives us no light. A cutoff of 0.2, 0.2 gives us a lot of light, almost a little too much light. So I found that 0.4 works reasonably well. And so that's the basics of our outline. So we can see now that we have it as white, but instead what we want is we want to be able to control the color of this outline. So let's say if we want it to be black, then we should have a black outline. But the problem is that we're getting just the colors of our diffuse mesh. And the reason why that's happening is because we're adding our color. We're adding the color of our outline to the lighting calculation for our surface. What we should be doing instead is multiplying so that the black areas turn black. So what we're going to do is we're going to take this, we're going to multiply in our surface calculation. So now our outline is going to more or less override. It's going to override what our surface lighting calculation is. And we'll just plug that into our output. And so now, as you can see, wherever it's black, it turns absolutely black. That might not even be completely correct either. What happens if we turn this white? Okay. So we're getting somewhere. Now all that's left to do is we want to just invert this outline calculation. So we can take this guy, we can take the 1 minus of it, and this will give us, it won't quite give us the ability to control the color of our outline, but at the very least it'll give us a pretty believable black outline. And that's pretty nice. We can experiment and see what happens if we change the rim light color, but I don't think we're going to get too much of a meaningful behavior. Why can't I change this color? Oh, that's why. So let's say if we give it like a green, what do we get? Ooh, it turns out that we get the inverted color of the outline. So we get the absolute, the opposite of the color. Well, green gives us pink. Maybe we can control this. Maybe we can still control this. So let's take the rim light color. Can we 1 minus the rim light color? Aha! And that's the effect we're looking for. Now we can control the outline color. We take the rim light color, we 1 minus it to get the invert. We use that to scale just how much we want this color to show through. And then we finally invert that once more. And we can multiply that into our surface calculation. And we get more or less a controllable outline. Whew, amazing what computers can do these days. Very nice. So now I feel like the last part of this, just to make this true to our original design, we just change our color to black. Call it a day. But you can always feel free to go back, change this, make it even more fun. All right, so we're about halfway there. We have an outline. We have, now the last part to do is we want to add our, that's right, we want to add our second level of diffuse lighting. So if we look at our original diffuse light calculation, we have a cutoff here. This cutoff is what allows us to control just how much, how strong does the light need to be for us to color it in with our diffuse color. So if we increase this cutoff to 0.5, for example, now we only get the more directional light. We're kind of narrowing just how much towards our subject does this light need to be shining for this layer of diffuse to show through. So let's say 0.8, for example, 0.9. If we change to 1, we get absolutely nothing, or we get almost nothing. You can see like a little bit of shining, but the compression might remove that from while you're viewing this on YouTube. So let's try 0.99. You kind of see what I mean. There we go. See? So I'm going to go back and let's try 0.8. That'll give us this nice, well-lit portion. And all that's left to do here is we're going to take our diffuse lighting calculation, and we need to figure out a way to get this diffuse light to play nicely with a second level of diffuse light. So how can we do that? Well, first off, we can just keep our ambient lighting calculations, and we can leave that over there. We don't need to mess with that. But what we are going to do is we're going to take our scale, and we're going to take a second step block, and now we're going to use a higher cutoff, or we're going to use a, this would be our diffuse. We can call this the bright cutoff. Ooh. Let me just make sure this is good, because I got to share this scene with you guys later. And we're going to call this one the diffuse dim cutoff. Okay, so for both of these, we can still take the same diffuse lighting calculation, so the same n dot L, and we're just cutting it off at different values. Finally, what we want to do is control what colors that we're going to use for these different diffuse lights. Or, sorry, we're going to take the same light color, and now if we want this to be dimmer, for example, we can say, hey, let's use our scaling node, and we're going to scale this input by whatever we want our dimming factor to be. So what this does is we take this guy, and let's just override what we're giving it now, and we want to dim it to a value of, let's say, half as bright. Well, perfect. Now we can control just how strong this light is, so we don't need to give it, an absolute color value of the light. This is a small improvement that I discovered when revisiting this. So now what we can do is we're going to take this light here, we're going to control it by a factor of what we want this to be. Oh, I'm sorry. So we're going to take the light, we're going to use, we have our two diffuse factors, so this will be how bright we want our bright portion to be compared to the input light color, how bright we want the dark portion to be compared to the input light color, and we finally also want to use our the other factor, this step function factor here, to control where we want this to be. Whew, that was a mouthful. Okay, so let's say this is our dim light color. We want one more scale. This can be our bright light color. Whew. And we're going to remove this link here. We'll just replace it with a float here. We're going to replace this with our original float here. This can be 1 because we want it to be fully bright. This is half, so it's half as bright. And now finally we're going to use one more scale. So this scale is going to allow us to turn off the bright light, or turn on the bright light only where we want the model to be bright. So essentially we just recreated our diffuse shader, but with extra steps. But the magic happens where we create a second scaling function. We tie that to where we want the model to be dim. And finally, we're going to go and multiply these two together. So this only really works when you're trying to make something dimmer in a certain area. But as you can see, now, something went wrong. What happened here? Let's just override this just to double check that we have the right math. So this is where we want the dim color to show through. And just to make this a little bit easier on the eyes, we're just going to put the diffuse lighting calculations through to the output of the shader, plus the ambient. We want to, oh, that's right. It's not a multiplication, actually. It is a max function. Let me explain why. So if we give it the dim lighting calculation, you see, or the bright light calculation, we see it's bright up here, but down here it's dark. If we give it the dim light calculation here, we can see that here it's dim and down here it's lighter. So if we multiply them two together, then we're going to get the worst of both worlds. Because when you multiply light, you get the darkness, we're masking out the dark portions, and we're masking the light with the dark portions. Hopefully that makes sense. So instead of using a multiply node, we want to use a max node, meaning that for wherever we're trying to color, whatever pixel we're trying to color in, grab the brighter of the two colors. So anywhere that's lit by both, we're going to shine through with the brighter color. Anything that's lit by just the dim color, we're going to shine through with the dim color. And so that's how you go from a two-tone toon shader, where we're just looking at lit and unlit, to a three-tone toon shader, where we start adding in extra levels of light. And if you want to take it another step forward, you can even add, 4 tones, 5 tones, however many you need. This is the basic pattern, where whatever you're doing, you're just taking the maximum value. You're scaling your light by whatever the contribution is. You're multiplying in where it's lit and unlit. And then at the end, you're going to have a bunch of max nodes all multiplexing in, the light. Okay. All right. I hope that was a good explanation. So now let's just plug in the rest of the shader calculation, and boom, we now have 3 tones. Beautiful. We can even go back to our original sphere and see, oh, sweet, 3 tones. And our outline is preserved because we decided to mask out the outline at the end step. And so you can already see that we're getting this nice toony effect here. I like it. I like it enough that I'm gonna try and see what happens if I give it this X35. That's right, this is the $35 million or $114 million plane. Yeah, man, I wish I could afford enough to buy one of these. And you can see here, this is more or less like what we can expect out of our final shader, where we have the slightly lit portions and they look quite nice. We have the fully lit portions, and then we have this overpowering outline. So there are ways to make better outline shaders, but it is more or less beyond the scope of what an enemy is currently capable of. Because that enemy only handles, we can only do a single pass in enemy. So you just grab whatever your lighting calculation is and you spit it out. But if we wanted to do, let's say, a edge detection, you can certainly do that using the high-level shading language in Babylon, but maybe I can go back and do a series on that some other time. Unfortunately for now, this is the best outline I can get you. You can try experimenting with Fresnel as well. Fresnel, more or less, is another way of edge detection. It's another edge detection light kind of implementation, and that'll give you more or less the absolute outside edge of your object. Or it won't give you the absolute outside edge, but it'll also just give you what's pointing towards the camera or not. Cool. So let's go back to our test node. And now let me show you how to get the dithering pattern. This has already been like about 10 or 15 minutes. So let's make this as fast as possible. So the easy way of doing this is you can just grab a texture. Grab a texture, and rather than making your dim light color some just random float, what you can do is just plug in, let's say, a channel of our texture. And let's make this, let's upload our line texture. And as you can see here, now what we're doing is, based on where in the mesh's UV space, we are sampling from this texture to see what gets colored in with the full light color and what gets colored in dark. And that works. It works. I don't think it's the optimal solution though, because let me just scale this up to make this look a little bit more attractive. Just a little bit better. So we use a scale node and drag out the factor. And let's use this scale of 10. And you can see we start getting these vertical lines. Very nice. What we can also do is, before we scale this, we can rotate it. So with this rotate 2D node, now what we can do is we can plug in our UV and we can plug in a rotation angle. And that's how I get that slight sketchy look to it, where we're rotating the lines by a bit. You can turn it up or down as much as you want. So we want a 20-degree turn, we want a 90-degree. Let's try something that is, there we go. That looks pretty good. Wait, did we even turn it at all? That's weird. Oh, we're rotating it and we might be scaling after we rotate. Let's try scaling, then rotating. And that might give us a bit more desirable effect. So we're gonna take the scale and we're just gonna switch the order of these around a bit. And that's better. That's a lot better. So now if we give it a 90 degree, we get that horizontal. If we give it a 0 degree, we should get it vertical. I like 40 degrees, or actually, let's try 35 degrees. There we go. That looks pretty good. Just messing around with different degree factors, different degrees. And actually, I think I got it in reverse again. I'm gonna just try reorder these one last time, just to make sure I understand what I'm doing here. You rotate, then scale, I guess. TRS, translate, rotate, scale. Okay, so let's try an angle of 0 degrees. Okay, let's try an angle of 1 degree, 2 degrees. And this might not even be in degrees. This may very well be in radians. So let's try pi degrees. It's in radians. So, little fun fact for people who don't quite understand the difference between degrees and radians. Degrees go from 0 to 360. So this is, say, if we're looking at the hands of a clock, 12 o'clock is 0, 6 o'clock would be 180, and then back up to 12 would be a full 360. Radians is just 0, pi, 2 pi. So let's give it a pi over 4, which I remember is 1.57 or so. Yikes. I don't know. We're just going to throw that in there. That looks pretty good. And so now, if we try to go back to our original model, or go back to our test model, you can see, this looks all right. Definitely looks all right. Like, I don't think there's anything necessarily wrong with it. You can see that the lines are pretty static, and it's dependent on how the model is unwrapped, which is my main issue with this, is that like you have to be careful of your unwrapping for this effect. You can see here, this airline glass here, we have to modify our shader because this glass was originally used to be a different material. And so we can't just throw it in and have it work. You can also see here, you get some weird areas where you can tell that the object was mirrored, and it might have the same unwrapping for both sides. They're just mirrored. And so it works, it definitely works. But let me show you just one way of turning this into what I like to call the chowder or the screen space shader. So what we can do is we're going to take the, what do we want to do? We're going to take the view direction. I'm going to cheat a little bit, and we're going to go to our original example where we take our, that's right, we're going to take the world position multiplied by the view projection, which will give us our object geometry in screen space, or roughly in screen space. It's like it gives us the object geometry in view space. So if we want to just visualize that, that is this node here. Just plug that in. And you can see here, we get roughly the object geometry in view space, but as you can see, we get some parts of the geometry all shows through. So it's actually the object geometry in world space. What we want to do is we're going to try and compress that down and turn this from a world space shader to a screen space shader. So I want the left part of this to be one color, the right part of this to be another color, top to be, so we're going left to right, black to white, and black to white, or whatever colors that, or whatever channels that we're using to represent this. So it might be black, red, and then black, green. So what we can do is we're going to use a vector splitter, and we're going to use a number of transform nodes. Special thanks to Cedric Guillemette. He is an amazing programmer and also a member of the Babylon.js team. He gave me just the secret sauce for making this work, where you take your view projection matrix and you divide all the components by W. and that will kind of take the, I'm actually not totally sure. It's 4-dimensional. It's hard to wrap your mind around, but it will transform it into a rough approximation of screen space. So we take x divided by w. We're going to take y divided by w, and we'll take z, and you guessed it, we divide by w. And we're just going to take that and join it back together. Oh, why am I? Merger. It's a vector merger. So we take the x, the y, and the z, and our output should be our screen space coordinate. And that'll be a 2-dimensional screen space coordinate. So we take the x, y, and let's see what we get. Sorry. Let me take the x, y, z and plug it in as our output color. And boom, look at that. So this is a very cool effect. I may go back and do a bit more exploration with this. Maybe try to show how to do some cool material and cropping effects using this type of shader. But for now, we're going to use this to drive our texture sampling. So plug that in here, and we need to reattach the rest of our shader. And oh, so much nicer. So what I'm going to do is, let me just reduce the texture repetition by decreasing the scale here. So instead of 10, let's go to 3. And you can see now, regardless of where this is on screen, it's almost like we're cutting through the screen to get this dither pattern. Yeah, if you like it, feel free to tell me in the comments. If you don't like it and you like the UV method, the UV unwrap method more, then feel free to tell me that as well. I love listening to, whatever you guys have to say. So I believe we're almost done here. Just one last thing, just to get this to our original. We're going to reorganize our nodes a bit, make them a lot easier to work with. It's a good technique. And finally, we're just going to add in, as I alluded to in the previous video, we're going to add in our diffuse texture. So this we can UV wrap, or we can UV unwrap. So we're just going to take the RGB of this, override the surface color node here with the RGB color here. And for our texture, I have this diffuse map here. And boom, we have a colored, comic book shaded X35 lightning jet. And yeah, we're pretty much done here. As I said before in the original, you can change this texture to change what your dither pattern is. You can also use sinusoids or what have you to drive this UV pattern as well. So it's very flexible shader, and I am interested in seeing what you guys plan to do with it, because this community is absolutely amazing, and I'm so happy to be able to contribute back to all these amazing artists and programmers I get to interact with on a daily basis. So if you like this video, please give it a like. If you want me to take on another shader challenge, again, this might just be a series now. Please, whatever suggestions, I am more than happy to listen to. As always, do cool things and keep being great.